Welcome to Kotlin. I hope that's what you're here for. I know that's what Pratik has been waiting for months.
I'm a big fan of Kotlin.
Big fan. My name is Justin Lee. I work at Red Hat for context. I work on a project called Quarkus, which is a microservice, microprofile framework. I do the Kotlin support there. So does anyone use Quarkus? Heard of it? So no worries. That's not what we're here for. Anyways, that's what I do. How many of you have used Kotlin before in production? But you've dabbled with it? Dabbled with it? Okay. Well, good. This is for you guys anyways, so if you've had experience with Kotlin, it'll be interesting, but maybe not groundbreaking. So I've been using Kotlin for a long, long time. I'm a huge fan. So that's what we're going to talk about. Now, I was just telling John, I stopped using slides years ago because I tend to show a lot more code than is useful on a slide to do. But it also lets me do my favorite thing is to make it interactive. So I have here this agenda that we're going to try and get through as much of it as we can. We'll see how that goes. But the way I like to do talks is I like it to be interactive. So as we're going over things and there's a nuance or I'm not clear about something, raise your hand and we'll try and tackle it. We can go back to stuff if whatever. But I designed this to be interactive. Because I've been to talks where you're like, that I could have just read a blog post and that would have been fine. And some talks are that way and sometimes not. But I always find it better if you can ask questions and interact and drill down on things. So I'm here for you guys. Ask away. So, all right. Here is the basic agenda. How many of you have seen Kotlin code before? Okay, a handful. All right. So we're going to start with the basics. So this is a valid class definition. Now you might notice a few things. There's no public keyword on there. How many are Java developers coming to this? Most of you. Okay. I'll make frequent comparisons to Java because that's my background and that's most Kotlin people's background as well coming to it. But you don't have to know Java to learn Kotlin, of course. But anyways, so the default visibility in Kotlin is public. When they were designing the language, they scanned, thousands of projects on GitHub. And the most common visibility modifier in the Java code was public. And one of the goals in Kotlin is to reduce boilerplate so that you have to look at less code and have to write less code. So they changed the default to public instead. And you'll also notice there's no curly braces involved. You don't have to have it. This is completely valid. You could create a new instance of basics. Obviously, you can't do much with it, but that's a valid class definition, right? So let's make it a little bit more interesting. Now we have a body, and let's define a property. Now, in Kotlin, there are two modifiers of note here. There's val, which is essentially like final in Java, and then there's var. Is anyone on Java 10 plus in their Java world? Now with local variables, you can say var, blah, 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 whatever. Same sort of deal. So var is a mutable reference and val is final. So you can only assign it once. So I use the same basic properties over and over again because I'm not that creative. So we're going to declare a property named name. You'll notice there is no type on that because the type in Kotlin, also this keyboard is not my normal keyboard, so I apologize for the thrashing. The type always comes after. So we're going to declare a string, a variable named name. It's of type string, and we can initialize it if we like so. So now we have a variable. We've initialized it to an empty string, okay? Now, one of my favorite, and I may or may not be jumping ahead here, but that's just fine. This is a new format, so I tried to rearrange it so it flows normally, but it doesn't always work out that way. One of my favorite features about Kotlin, and you may have heard about it, is it has nullability in the type system. In Java, if you get a reference passed into your method or whatever, it may be null, and you just don't know. And you always have to say if foo not equal null, blah, 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 or you risk null pointer exceptions. So Kotlin mostly fixed that by adding nullability into it. So right now, name is a string. You can add the question mark to create what I call a string. So here, string might be null and it might be not. So we could do this. And that's valid, right? But if we take away this question mark, now we get the red squiggly, if everyone can see that, because null is not a valid value for that reference anymore. So whenever you see a name being used anywhere, you can be guaranteed that it's not null, and you can just use it. And this fixes, I converted a large project from Java to Kotlin once, and I caught so many places where I should have been getting null pointer exceptions, but I just got lucky, just from converting it to Kotlin, which was nice. So another thing I want to point out, let's declare another one. Age, you'll see name and age over and over again because, again. So Kotlin has a number of types. It has float, double, char, short, Boolean. All your wrapper types in Java, you can use in Kotlin the same name. The difference is int. I don't know why they did this. You can have int instead of integer. So the difference is, see there, I initialize it to 0. So everything in Kotlin is an object. Now for the performance-minded among you, you might think numbers as objects, terrible performance. Yes?
So Kotlin seems very closely related to Scala. So how closely related, and do you know the difference?
There was a lot of inspiration from Scala. They took a lot of ideas from Scala and from Java and from some other languages as well. But it was designed to be much simpler. I heard it once described as a journeyman's language. It's journeyman. It's meant for just your normal developer. If you've ever done a whole lot of Scala, you get lost in category theory and type calculus and monads and whatnot very quickly. With Kotlin, you don't normally get there. You can, because it supports a high degree of functional-oriented programming, but the community is a little bit less, monad, as opposed to Scala. But if you know Scala, a lot of these concepts will make a lot of sense. So, all right, so back to int. The problem with int being an object is that's terribly expensive, not to mention creates a lot of garbage, because it's another object on the heap somewhere. Here's where Kotlin gets very clever. How many of you can read bytecode? Probably not too many. I couldn't until like 3 years ago because of my job made me learn. But that's okay. So it's compiling. Here we go. All right. So this is the bytecode for the class that we're looking at. You can see here it's a public final class. There's basics. It's compiled from that. This is metadata that Kotlin adds. You can ignore it. I don't know what it means either. You can see we have a private string called name, and it's annotated with a nullable. That's how Kotlin keeps track, because we have the question mark. Now, if you come down here, here is age. Now, this is what an object looks like. Every object reference in bytecode will have L, and then it's the package, the fully qualified name with slashes instead of dots, don't know why, and a semicolon. That's what a type looks like in the bytecode. But if you'll notice this is an I. And what the I is, it is the bytecode symbol for int instead of integer. Because what happens is, the Kotlin compiler is smart enough to know if it made every object in your or every number in your application an object, performance would just vanish, right? So if it's an int as opposed to an int, you get the I. But if we switch it back to the question mark, you can see down here now, see how the age changed? So now that age can be nullable, it uses the object, because an object reference can be null, but a primitive cannot, right? So you get kind of that performance benefit for free. So just never use a nullable number type in Kotlin. You're probably fine. It doesn't often make sense to have that anyways. But those are the basics of properties. We'll get to some more stuff here in a bit. And I'm doing it in this order because we're going to do all like unit testing to see this stuff in action here in a second. Yes?
When you had the question mark on int, it was like highlighted green. So is IntelliJ trying to tell you something there?
That warning, the question mark here, this warning says age is always a non-nullable type because I initialize it to a 0. I don't know why it warns you, because obviously down the line it might be null, but in this case it complains. It's because it's val, so age can never change, There we go. Now at some point it might be null, but because I declared it with a 0, it was never going to be null. That's the difference. All right, so functions, real quick. So all function definitions start with the word fun. They could have used def like Ruby and Scala and Groovy did, but they chose fun. You give it a name, take some parameters, and you give it a body. Now, the Java people will notice there's no actual return type to this function, right? Because again, Kotlin tries to reduce boilerplate. If you do not give it a return type, the default is this thing called unit. Unit is roughly equivalent to void in Java. But if the return type is unit, why bother declaring it? You don't care about the return type. Why take up the space? So you can actually leave it off, right? But you also notice that it's at the end of the function declaration with a colon. So all the type declarations like this are going to be some sort of identifier, colon, and then the type. You're going to see that everywhere for extensions and interfaces and whatnot. It's just how it works. So if you want to declare it to return a type, you would just give it like that. And then you can do whatever. And of course, it should, yeah, there's a red squiggly down here because we're not returning anything. So we're going to do this. So we're going to return hi. One nicety about Kotlin functions is this is a very simple function. It's a one-liner, but it's currently taking up 3 lines. So one thing that I really like to do is you can do this. You can convert it to an expression body, and then it looks like that. So if you have a whole bunch, and there's a couple of classes I've done at work that have a whole bunch of like really simple whatevers, you can convert it to this expression body, and it makes it so much easier to read because you're not having to skip lines and curly braces and whatnot. It doesn't always work out. You can actually start this way and realize as you're getting into it, like, oh, I need more stuff here. So if you're using IntelliJ, you can convert it back to a block expression as well. Pretty straightforward. So those are the basics, right? Any questions before I move on? What is the, oh, wait. What is the which?
New start, the new start about fun.
Oh, this is I have this in Git, so I can revert changes when I break things. And that is an annotation that IDEA adds because it is new to the Git repository. If it was an existing function, if a coworker had changed it, it would list the Git username that had changed that line of code, but it's new. You can see here, my Git handle, my Twitter handle is Evan Julie. So you can see these are like existing lines in the Git repository, and these are all new. So it doesn't know who wrote that yet, but that's all it is. Let's close that. Okay, so let's look at something else briefly. You'll notice in the last one that there was no package declaration, right? Which is fine. Java supports that too. Where Kotlin differs a little bit is Java gets really persnickety if the package name does not match the layout on the file system. It gets really cranky. It used to not care, but I think now it actually gives an error. Kotlin does not care. You can have the package be whatever you want it to be, and if you look at the project structure, you can see there is no, here's the root of the Kotlin folder, there is no package, there's no directory structure, it is just the file itself. So the package can be whatever you want, completely unrelated to the layout. I don't recommend that because it makes it very difficult to find things if you're not in an IDE. I still tend to follow the same structure because I've been doing Java for 87 years now, and it's just ingrained into me. But while we're here, let's talk about imports because they mostly work like Java does. So let's see if I can remember. Let's see, Kotlin, let's just import random types because it doesn't entirely matter. Let's import something from Kotlin streams dot, oh, and of course there's not going to be any types there. The things that are there we'll get to. Well, let's just do this. Let's import java.util.list. Now, Kotlin has its own list for reasons we'll get to in a little bit, but you can import the Java types directly if you want. But if you do that, it'll conflict with the Kotlin type, right? Because now you have the two types that are the same name. But what Kotlin will let you do, which I wish Java would do that, you can alias it as Java list. And then when you come down here, you can say var list Java list of some type, and then you can say var others as just list. And then you can see, if you can see in a little pop-up, it says kotlin.collections.list. And then you can have two different types that are both technically lists, but you've aliased away the other one so that you can have both of them in the same file. Hopefully you won't have to have that a whole lot, but it comes up, and it's nice to have that in place. All right, so visibility. I mentioned that the default is public, but I didn't really tell you what the options were. So much like Java, there's public, as this is by default public. This class is also public, aptly named, and you can see the public is grayed out because IntelliJ will tell you this is redundant, you don't need it. You can also have a private class, much like this class called private. And then you have this internal class. Now internal, I've honestly never used this because it's not terribly useful for me. And it gets a little confusing because what internal means, it means it's internal to this module. And if you're a Java developer, when you hear module, you think the Java module, right? The Java Platform Module System. Or if you're a Maven user, you think Maven modules. So Kotlin also used the word module. And in Kotlin, what a Kotlin module is you can roughly equate it to like a Maven module. So it's that one particular compilation unit. You can use it anywhere inside that, different packages, sub-packages, no packages, whatever. You can use it wherever. It's like a package private on steroids. But you cannot use it in another library because it's internal to that guy, if that makes sense. So it's a bit bigger. It's sort of like public, but only within my project. And so you can use that to keep from exporting types to users or downstream clients or whatever. It's not used a lot in my experience. But yeah, so right. So quite quickly, we're going to declare. This is why I did it in the order I did, so I can show you unit tests to watch things work. This won't be terribly interesting because it doesn't do anything. But if you want to create a new class, if you want to instantiate a class, with the class public up above, you just say public and you pass it in parentheses because you're invoking the constructor. But you'll notice there's no new keyword. Again, because new, it's really just line noise, right? Even in Java, like, how many times do I have to tell you to do not disturb? Sorry. It keeps turning itself off. It's just line noise. It's redundant. You know you're invoking a constructor, and it's just there's no point. So Kotlin does away with it altogether. It's not even like if you want to declare something public, you could use the redundant keyword. With Kotlin, it doesn't even recognize new as a keyword. It's just why bother? So it'll streamline your code that way just a touch, which is nice. It adds up. All these little tiny things eventually make a lot of sense. All right. Now, before we move on, there's another concept called an object. How many of you are familiar with the singleton pattern? You ever tried to write one that's like really actually a singleton on the JVM? It's complicated. There's like double locks and initializations and checks, and it can be very complicated. I've cheated by using an enum as a singleton because you can't instantiate an enum value. Not what they were meant for, right? So in Kotlin, much like Scala, if you know Scala, there's a type called an object. And what that is, it's a class, just like every other class, but the Kotlin runtime will instantiate this one for you. You can't instantiate it directly, and you get exactly one. So it's compiler runtime enforced singleton for a particular type. Really useful if you have like some sort of utility or whatever, but you get exactly one. and you cannot create more of them. But the same rule as classes apply. You can add a body, you can add fields, you can add functions, all sorts of fun stuff, and they work essentially like classes, except let's just do class, whatever. If you wanted to use it, you could do something weird like this. You could say var equal, and what did we call it? I am an object, of course. You could do that. And if you wanted to, now Bob is a reference to I am an object. Notice there's no parentheses because we're not constructing it. You're just referencing it. But more importantly, you can do, if you had, I'll just put fun Bob up here. And it, down here, you can actually do it this way instead. You can invoke methods against it, because I am an object is the named reference to that object that's visible depending on what the visibility of an object declaration is. And you just reference it directly, which is useful. Now, where that comes in most of the time, if we have a class, say we're modeling some sort of a user inside of a system, every class in Kotlin comes with what's known as a companion object, okay? And it looks just like this. This is also a valid declaration. There's no body, there's no nothing. This is the companion object for user. And every user shares the exact same companion object because it is an object, okay? Now what this is useful for is one thing that Kotlin does not have, that Java does, is static. There are no static members in Kotlin anywhere. So if you wanted a static function to encrypt a password or validate an email or whatever, you could do this. And now, if you wanted to do something with it, how you'd use that, you could actually do things like this. You could say user.validate. And you would just reference it directly as if it was like a static method on the user type. So that's companion objects. And they're useful in a number of different places. Does that make sense? Any questions? Okay. So, let's talk. Oh, yes.
How do you access the instance of the user that you're validating in this case?
Oh, well, in that case, nope, not that one. Objects. So here you would say val user equal user, right? So if you wanted to access that particular instance, you would pass it in as a parameter. Because it's like a static function or static method. You'd have to give it something to pass into. Good question, though. Okay, so let's talk functions because they are a little bit different than what you see in Java. So here we have a class, and you can see there's a function, a file. You can see there's a function, but there's no class, right? In Java, every method has to be a member of a class. Even if it's static, it goes into a class somewhere. With Kotlin, not so much. You can just put them wherever you want. You put them in a file. And they're scoped similarly. So this can be public, it can be private. If it's private to that file. You can have as many classes as you want. You can have as many public classes as you want in a given Kotlin file. And this function, if it was private, would be private to those classes inside that file, right? And then, as you can see here, let's close this because it's eating up my screen real estate. As you can see here, we're calling example just out of the blue. We don't have to prefix it with the class or whatever. It knows where it is. Now, how this works in practice is if we go back to, we won't look at the bytecode because it's not as interesting in this particular case. There are two things that happen here. You'll see we have a class called testing in this file. So you'd expect to see a testing.class in the compilation area, right, in the build target. So if we come down to here, we can see here's our testing class, which just has the one function. But then you see this guy, right? And if you'll notice, this file here is called toplevel.kt, and that compiles to a toplevel.kt.class. So any top-level members you have, there will be a class that is synthesized for you, and all those functions live on that class now. So if you were to import it elsewhere, especially if you were to import it through Java, you would likely see top-level KT, like import blah, 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 top-level KT would be the class name. And that's how you would import those. But they all do end up on a class because the JVM requires it ultimately, but the Kotlin language itself does not. Yes?
Is the stitching dot class, is that similar? I mean, those dot class are Java.
Yeah, it's a legit class. Let's just take a look at.
So what's the stitching on Kotlin?
What's the what?
Extension?
For the source files, it's .kt, but it all compiles down to a .class file once it's compiled, and it's mostly normal Java bytecode. They do some funky stuff in there every once in a while. You can see this is what the bytecode looks like for that synthesized class. Yeah, so there's the access flags. There's some metadata associated with it, but then there's our function definition, which does not a whole lot. It does actually nothing. So those are functions. Those are useful. Honestly, I do a lot of like utility methods, like shared whatever as top-level functions, rather than hanging them somewhere. You can do it either way. They both work. All right, let's get into parameters, because this is where it gets really fun. So here we're going to, let's print out, I have some aliases involved. I have a bunch of stars there because I use this macro for work, and sometimes when the logs are 80 miles long, it's hard to find out where I am, so I put these stars in it so it like stands out as I'm scrolling through the logs. Oh, there they go. Because then I print it out like 20 times, so it's just like a big block of stars in the log. Anyways, it's clutter here, but it's useful to work. So, all right, so in this, let's see, we're going to create parameters, and then we're going to call that function, and it was example, and we're going to pass in Jim Halpert for the Office fans, and I don't know what his age is, 35. I don't know how old he is. But if we run it, compiling, you can see, I fixed the logging. It doesn't matter. You can see we print out the name and we print out the age, right? So nothing terribly exotic there. But the feature that Kotlin has that I really wish Java would adopt, but I don't think they're going to do it, is default parameters, right? Sometimes you don't necessarily want to pass every parameter because normally there's like, I always do this, so you can provide a default. So you can actually change it. We're going to make Bob by default, and his default age is 42. So if I run it again, which we just had, we will still get the same output because we passed parameters. However, if we drop the age and run it, Jim now becomes 42 because it defaulted the age parameter. And if you ran with nothing, it would default both of them, of course, and we should get Bob, who is the ripe old age of 42. So that can reduce some line noise. However, sometimes you really do want to pass in some parameters, but not necessarily all of them, right? So the option here is you can either just pass in like dummy values or like force it or whatever. This is useful, like, you know, if you've ever written a Java method and you have to overload it like 4 times because there's like one that takes like a whole bunch of parameters, but then there's like a more convenient one that only takes like 1 or 2. Then you have to like keep calling down and keep delegating to the final one. This solves that for you. But if I just wanted to pass in an age, if I really wanted Bob to be 18 again, oh, the life, right? You can just pass in the one parameter, but you can't just pass it in raw because 18 is not a string, right? But you can do this, and now if I were to run it, Bob is 18 again. Oh, the joy. So you can actually you can reference it by name, so you can pass in just a subset of the parameters that you really want. So if you have like 12 parameters, you can pass in just the 3 or 4 or whatever that you're interested in, and reduce some boilerplate that way. This is super handy. Yes, sir?
In that case, don't we need function overloading for Kotlin?
It depends on why you're overloading. If you're taking like an entirely different set, like if you have like a process method and one takes a PDF and one takes an XML file, that would be an overload because it's 2 different data types in that case. But in this case, if you just have like some default parameters that you don't want to require someone to pass in every time, you don't need to overload for that. You can just default it and reduce some code that way. Now the downside to this is it does make the parameter name part of the method's signature. So if you ever change the parameter name, sometimes you're like refactoring code like, that's a dumb name. You change it, you're now going to potentially break people who've tried to use that as a named parameter because they've used the old name. If you're in the same project, I think IntelliJ will fix those for you because it knows about that context. But if you have like an external user whose code isn't in your IDE, you're going to break them because they won't have gotten the memo. So just be careful with that. Well, that's a good question. I think you probably could, but I have not tried. Let's see what happens.
You can, but you must pass a value for every non-default.
Right, exactly. So if we did this, yeah, so that still compiles. You can still, but you will have to pass in all the. Correct. Right. There's the red squiggly. I don't know if you can see that there. I almost couldn't see it. That won't compile because there's no default for a name. But that's a good question. Probably. Yeah. It's a little weird, but it's doable. All right, let's see. That was top level parameters. Okay. Lambdas. This is a little bit in the weeds, but I couldn't think of a better place to do this. So here we're doing, everyone's used Java streams by now, right? Mapping and blah, blah, blah. Kotlin, of course, has that same functionality as any reasonable language would. And it looks like this, okay? Now you might notice there's a whole bunch of like little yellow squigglies because Kotlin has a very nice feature. If you have a function that takes a number of parameters and the very last function is a lambda, the closure of some sort, you can actually move that lambda outside of the parentheses, right? And you may think, that sounds weird, it doesn't sound very useful, but it changes that to this. So it's a little bit less code to look at. You're not having to like parse parentheses and this and that, and it cleans up your code a little bit. But more specifically, what's that? Yeah. So it's a slightly cosmetic change, but it lets you do some nicer things. Let's do all of them because gross. Fix all. It lets you do some nicer things because there are sometimes, like if you've ever passed a lambda in Java and it's like a multi-line thing and down at the very bottom you have like the closing parentheses and the semicolon and you lose track of it. Sometimes it takes some work to find like where I'm imbalanced somewhere but I don't know where. This reduces that a little bit, but it's also really nice here. You see the one thing it didn't change here is we're passing a separator to our join, and we're passing in a function to transform the strings. This one is still in the parentheses, and you can see we're passing in that guy. And unless I messed up, we can move the lambda out of parentheses there as well. And you can see we're joining to string with a separator, and then you can consume that part, like what am I passing to the function, fine, and then it lets you evaluate, read and process what your actual function is, the lambda that you're passing in, a little bit separately. Again, it's not like a life-changing feature necessarily, but it is the amount of clutter that it removes from the code. It really does pay off in the long term. Make sense? All right. What next? Okay, so properties. Much like functions, you can have top-level properties. and they function just like everything else. They will also be attached to, in this case, top-level kt.class, and you have two properties. And yeah, you'd reference them like you would any other property. If you import them, you can import them directly. If this was in a package, you could import com.foo.bar.top-level and then just, or top-level.name, and then just reference that name field as if it was just there. So you can import them directly. And so all the other rules, the same way with functions, apply here as well. We talked about nullability, but let's talk about nullability. How many of you use Spring or Juice or some sort of injection, right? You know you're going to get a resource of whatever it is injected, right? But you don't know what it is yet because the system's going to inject it, right? So normally what you would do, because if you just had a non-nullable value, you have to give it a value of some sort, right? If it's a string, fine, you can initialize it to an empty string. It's wasteful, sort of, but not terrible. But if it's a complex type, you know, you can't just give it like a random thing. Or you can declare it null. But then once you declare it null, you have to deal with that nullability factor all through your code, even though you know in your soul that it's going to be not null by the time you need to use it, right? So it gets annoying very quickly. So Kotlin added at one point this thing called late init. And it's a modifier that tells the compiler, I know I haven't given you a value, but trust me, by the time I try to refer to it, something is going to give this reference a value. So don't complain yet. Now, you can do this. Let's see. Late init. Now, if I tried to print out name, what do you think is going to happen? Yeah, it's a big ugly error. Uninitialized property access exception, and it'll tell you the late init property name has not been initialized because you tried to use it before something gave it a value, right? So if you're doing like injection, like field injection, and you try to talk about it in the constructor, for example, before Spring can come in and inject your auto-wired whatever, you'll get this error because the constructor runs first, right? So if you try to use it before you initialize it, you'll get that terrible looking error. But that's a runtime error because the compiler won't know, right? But you can initialize it, of course, to good old Bob, who's enjoying his best life as a newly 18-year-old. And now you can get the value back out, right? So it's nice, especially if you work in environments with injection, and we'll see some other use cases where it's also kind of interesting. This helps you maintain the use of a non-nullable type because that's what you ultimately want without necessarily having to do all the work up front. All right, that is late init. There's more to say roughly in that area, but we'll get to it. How are we doing on time? Okay. Let's speed up. All right, so constructors. So this is a class with a no-arg constructor. And that's it. That's all you need. Now we have one constructor. But if we want to give it a parameter, we can say name string. And now if I tried to instantiate this, we'll say constructors. It's not going to work. You can see it's, I need a name. You give it a value and construct it, okay? And then you can, like with anything else, you can give it a whole bunch of parameters if that's what you need. And those are just constructor arguments. The life cycle for those are as long as the constructor runs. So once the constructor is run and the object is initialized, name is no longer available, okay? But obviously we want to store that somewhere, right? So we saw a couple of choices earlier, right? We can say var name, right? But we don't have a value for it, but we want to set it in the constructor. Okay, so we can come back here. Now we have a constructor argument and a property called name, but you can see it's red because we still haven't assigned it a value. Now you have two options here, depending on what you're doing. Sometimes you'll want to do this. You can do an init block. This is like the default constructor body if you want, and then you can say this.name equal name. Now you can see I'm using the same reference name in both places, but one is purple because this is the property, and if you control click, you can see this is the argument to the constructor. So if you just have values you want to pass in to the constructor and then manipulate them somehow and store them as a property, you can do it this way. It's a little noisier than it needs to be, but you can also do this. So we have this guy, and if it'll let me do this from here, you can see this move to constructor parameters, right? Do it. Now, it looks exactly like our old constructor, except now there's a var keyword in front of it, right? Val is also a valid name. And what this syntax means is not only is name a required argument or parameter to your constructor, so you have to pass it in when you're instantiating your class, but it's also a property, so it serves two purposes here. So now there is, there's the home key, var c is equal to that. We can do c.name, and you can see that resolves, it's purple because it's a property, and without that keyword, now it's red because it doesn't exist on that type. Like so. Okay, so those are constructors. You can do secondary constructors as well. I don't know that I'm going to go into that one because it's, well, I'll show you an example. I don't want to run out of time on some other stuff. So here's our properties in the primary constructor. And the secondary constructor is our noarg, if for whatever reason. All the constructors are named constructor, which is useful. It's very clear what that is. But you always have to call a primary constructor of some sort. So you can say this and then pass in values. In this case, of course, you can use default parameters here. If you always want Bob to be 42, you can do default arguments like you would with a normal function. In this particular example, we're just doing it through a noarg constructor. Both are valid. I honestly don't do this secondary constructor a whole lot. It's not terribly common in my usage, but you know, your mileage may vary, of course. All right. Properties. All right, let's talk about class extension real quick. This is the parent class. Has an age and a name that we've swapped order in, creatively enough. So if we're going to extend that class, it's commented out because it won't compile. So we're going to create a child class, and as you can see, there's the colon, because that's how Kotlin works, and we're going to extend parent class. But you'll notice it's in red, right? Because the problem is, in order to subclass, you have to call the parent constructor somehow, right? So you would do this. And that invokes the parent constructor of the parent type. But we don't have any parameters there because, it's an error because we don't have any parameters, and the parent constructor takes one. So we can add in, we can either add in actual hard-coded values, and then that part at least is not red. Yeah. Now you'll notice that it's still red. Can anyone guess why, except for this guy, because he already knows? By default, every class, every function is final in Kotlin. It's a choice they made. I don't always like it. It causes problems sometimes. But that is the default. So I can't extend parent class because it's a final class. So to fix that in Kotlin, you can make parent class open. And now I can subclass. Now the nice thing about this is, there's the whole philosophy like you should design for inheritance. Like if you're going to have a non-final class, you should make sure that your subclasses can't mangle your class because they're poking at things they shouldn't. Making them final by default makes that choice a little bit more explicit. Like I intend for this to be subclassed, so you take proper precautions to encapsulate and blah, blah, blah. But yeah, so open is your friend if you like to subclass, or if you use Hibernate or virtually any Spring technology that does a bunch of reflection proxying stuff, you're going to want it open. There's a plugin that will do that, that will automatically open all your types, so you don't have to keep littering open everywhere. That's a separate thing. So that is extension. Now the distinction, an interesting thing to point out here is in Java we extend a class but we implement an interface, right? Kotlin, we're not extending a class, we're coloning a class. So whether it's a class or an interface, look exactly the same. The difference would be, let's say we wanted to make this guy serializable, which is a terrible interface, and you shouldn't use it. But you can just do that. No parentheses required because it is not a parent class. There's no constructor to call, right? But just like Java, you can only extend one class and implement as many interfaces as you want. So that still holds true because that's just how the JVM works. And all right, we just saw that. Let's see, 2:05. We have about 15 minutes. Let's see. We saw streams. We saw that. If you just really want to see it in action, again, that's with the Lambda. You can move it out, and if you run it. Now, it is worth noting, we've seen the syntax, so that's not necessarily interesting. But it is worth noting, oh wait, that ran the old guy. This test is, scroll here. The difference between Kotlin streams and Java streams is in Java streams you have like a terminating operation. So that's like your collect or your for each at the end. And until it hits that function, no work is done, right? So you're just building up your pipeline, and once you hit that terminator function, then things start happening in maps and folds and whatever else is happening in your pipeline. That's when that happens. And everything else is just streamed step by step by step. And that's fine. Kotlin is a little bit different in that every step is potentially a terminating operation. So every map that you do is going to take your entire map or your stream or whatever, or your list or your stream, and it's going to run every item through map. And then the next step, if it's another map or whatever, it's going to take everything and run it through that map. So at every step, you have a usable collection of some sort left over, depending on the output of your pipeline step. That's not necessarily what you want all the time, because you run into some memory issues if you're working with very large data sets, for example. You don't want to keep processing over and over, because then you're creating separate maps of stuff. So if you want the behavior to be more like Java, you can actually you can do this, if I'm not going to mess this up, as sequence. So it converts your list to a sequence, and then it does stream everything through the pipeline all in one go, as opposed to each step. So it processes this. It looks, from a code perspective, it processes the same, but it's slightly better, potentially, performance and memory-wise, because it doesn't have all these intermediate steps that it has to go through. I never do this. I never have data that large. It requires such care. All right, let's see what else we saw. Destruction. Okay, now we're into the part that's just cool little features beyond just syntax that makes life interesting. All right, we've all written static utility methods in Java, right? To do weird things to strings or whatever, right? So in this case, we have this function called no spaces that takes in a string, and it does stuff. It takes all the spaces and strips them out. So you're left with no spaces, right? And if we look at that, we get, you sit on a throne of lies. Elf fans? Anyone? 'Tis the season. So this is how we would do it in Java, right? You'd write a static function, you'd put it somewhere, and you'd pass in the string that you want. Where this starts to suck is if you're doing Fluent APIs. It's sometimes you have to break out of your Fluent flow, because you have to stop, save a reference to your thing so you can pass it to the static function and take that return value, then pass it back to the rest of your Fluent flow. It works, but it's not pretty, right? So Kotlin offers this thing, and if I remember right, it'll do this all for me. Convert member to an extension. Let's see if it does this properly for me. No, it doesn't. All right, so Kotlin has extension functions, which is when you can attach a function to a type that you don't necessarily even have to own, okay? So we're going to do this. We're going to convert this to an extension function. So now we're declaring that we're going to create a function called no spaces, and it's bound to the receiver type of string, which then means we can do this. And, it's going to, line is a property up here somewhere. So that kind of ruins things for us. But now, you see, we're just calling replace, right? Well, where does replace come from? Well, that's the string replace method. So there's an implicit this on that function call. And then what that lets you do is you can come back up here. You can see now it's all red. You can say that. So now it looks like you've added a method to string, which you haven't technically because you don't own it. It's still a static method off in the bytecode. But what this lets you do is it lets you inject functions to improve the flow of your code without having to like break out and do some odd things. And you can attach functions to just about anything you want. There's also extension properties, but they're weird. They feel weird. Well, here's one right here. So if we have this string here, it's just the alphabet. We want to attach a property to that string. That's the rot13. If any of you are crypto nerds, you know rot13, right? Highly secure. All it does is it literally adds 13 to every letter. So instead of ABCD, you get NOPQ. But it looks like it's a property on a string when really it's not. And you can see this is what that looks like as well. So it looks just like a function. There's no parameters. There's no parentheses to it. And you can see my highly complicated implementation. So extension functions, extension properties. I never use extension properties because I think they're weird, but extension functions are super, super handy. Close the other tabs. All right, expressions. How many of you have upgraded to Java 19 already? Yeah, that's what I thought, which is fine. I haven't either. In Kotlin, everything is an expression. So how many of you have you want to return something, but you have to catch an exception. So you're like, try, blah, 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 return, catch exception, return, blah, 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 right? It's not great. It's not terrible, but it can get awkward. With Kotlin, that's actually an expression. So try is an expression. If is an expression. Kotlin has when as opposed to which or switch. I don't know why they chose a different whatever, but they did. So in this case, we are using when as an expression. So we're giving this guy, and we want some special output depending on whether or not the x variable that we're passing in, if it's a string or if it's an int. So is, in this case, is Kotlin's version of instance of. A little bit less verbose. So there's a couple things going on here worth noting. Kotlin uses something which, if I'm not getting it wrong, it's called flow typing, right? So in this case, we're saying when x, and the first case is when x is a string, we're going to do something with it. Now, if you'll notice, x is an any, which is basically like object in the Java world. So x is basically doesn't have a type that we know of. But we're calling lowercase, which if you're familiar with Strings API, you know that's a function on string, not on any. But because of the way the Kotlin flow typing system works, you did this is string. So in this particular branch of your when, it knows that x is a string. So it will resolve any function calls or whatever against the string type. So you can just treat it as if it were a string. In the same case with x, it makes no sense to multiply strings together, no matter how much Python tries to tell you separately. And now this. Especially if you're using it as an expression, you need it to be exhaustive. You need to have every branch covered, right? And if you're in this particular case, there's really no way to do that. X could be anything, right? So this is the else branch in when, and to do is a special function. It looks like this. It returns nothing, which is the opposite of any. Everything extends nothing, right? Or everything extends any, right? Eventually, everything gets up to any. Nothing extends everything. It's a subclass of everything. It's weird. It's basically a flag to the Kotlin compiler saying this function is never going to return. It literally returns nothing because it never returns. Because in this case, we're throwing an exception. And when you throw an exception out, you don't return. You just unwind the stack and you're done, right? So nothing is that keyword that lets you know nothing comes after it. And that's useful for a number of different cases. In this case, we don't care about If it's not a string or an int, it's going to do this, which means it's going to throw an exception, and you'll actually get an error if you give it anything other than a string or an int. It'll just throw an exception out. And to see that in action, you can see the output is hello, and if we change x to fan favorite 42, run it again, and you can see now output is 42 times 42. But the flow typing lets you do weird things like that, and then you can just return the value as, you can assign the return of that when statement to a variable. As opposed to in Java, you'd have to like declare a variable up top, do your branches, and then assign it, and you're trying to figure out like where is this assigned. Much more succinct option. Try is the same way. You can output, you can either return this string or return that string, and if you run it, you can see output should get, it works. But if something happens, the network is down for whatever reason, and you run it, you don't get, oh yeah, you get oops, because we did it in the catch. So try is an expression as well. If it's the same way, this is the same example as the when thing. All right, let's see. It's all right, we got like 2 minutes left. There's a number of really interesting things. There's destructuring. The one thing I wanted to show, because Java 19 just came out, and we have a preview of Loom. Everyone familiar with Loom, the lightweight virtual threading thing? It's very cool. It has promise, but I find it lacking in ways it's not Java's fault or the team's fault. They're doing amazing work. So who has written concurrent code in Java? Lots of threads. You have your executor service, and you're submitting jobs. All right, so here's what we're going to do. We're going to do that example. We're going to create a thread pool with 10,000 threads. We're going to start them all up to begin with, and then what we're going to do is we're going to offer in a whole bunch of jobs. That's all they do is they sleep for 1 second, and then they increment this atomic integer. And then when it's done, we're going to sit here and we're going to wait for it, at most 30 seconds, because we do have places to be, and then we're going to print out the value. So it's going to do that. Now, because I've run this demo a number of times, I'm going to go into the next part and we'll come back to it. We're going to Rachel Ray this thing. So this is what the coroutine version looks like, right? Coroutines are amazing, and they're quite complicated internally, but they make some really interesting things. So we're going to start off our coroutine context with this function called run blocking, which basically says we're going to run some coroutines, but I want this particular call to wait until the run is done, right? And so it's the same thing. It's the atomic integer. And this is a shortcut. We're going to create a list of size 10,000, and we're going to launch. This is to spawn a coroutine, and again, we're going to sleep for 1 second. We're going to increment, and when we're done, we're going to print it. All right. So our thread thing just finished, and it finished in just under 32 seconds. Who wants to guess how quickly the coroutines version is going to run? Are you ready for this? Now, this is just a dumb example. I get it, but it's for me, it's like illustrative. No, wait, that's the thread example again. Click the wrong function. Coroutines, run. Oh, is it doing both? Oh, it is running both. Why are you running both? It's running both. Well, it'll just drive the home point, and it'll be done. Because we are officially out of time. If I had more time, I would up it. You can do like 1 million, and the thread version just explodes. It just melts down. The coroutine version, however, all right, so the coroutine version ran in 1 second and 204 milliseconds. So 1.2 seconds to run 10,000 jobs compared to the 30 seconds it took the executor service to run the same jobs. They're just so fast because the magic that coroutine does behind the scenes. Loom will change this. I don't know how yet, but it'll narrow that gap at least. But like I was just saying, like I could literally spin up 1 million coroutines and it would finish, I think last time I ran it, in 6 or 7 seconds. And the threaded version won't even start because it tries to spin up a million threads and the JVM runs out of heap space or something. You'll literally crash your JVM. All right, there's a whole bunch of other stuff. Just real quickly, I was going to show there are a number of ways to use Kotlin. I'm not an Android guy. I've never written an Android application, but every time I tell someone, like, I like Kotlin, they're like, oh, you're an Android guy. I'm not. I write backends and database drivers. So you can use it, like I said, I work on Quarkus, so if you write microservice sorts of applications, you can use that. Spring Boot supports Kotlin for all the Spring types, which is most of you in here. There's one called Ktor, which is like a pure Kotlin version of it, and there's some really interesting stuff in there. And this other project, which is called JBang, which is a whole other thing. You can actually write scripts in Java or Kotlin. But anyways, there's a number of ways you can use it on the back end. You don't have to be an Android mobile developer to use Kotlin, and I use it every chance I get on the back end as well. So we're out of time. I didn't quite get to everything, which I thought I might not, but that's okay. Are there any questions before the next speaker comes in and starts eyeballing me? Okay. What's that? Oh, he's here. He's already eyeballing me. Okay. I'm around. I'm happy to answer questions. If you see me wandering around, feel free to stop me and ask whatever you want. So thank you for coming. I hope it was helpful.